implement MP-BGP. Okay, this topology, 3 routers, you can use this router Cisco 7200. This is my Cisco 7200 with iOS 15.2. Okay, 7200 router with iOS 15.2. Okay, 1, 2, and 3. Okay, between R1 and R2, gigabit 000. In my case, I will use gigabit 00 on both sides, 00. Gigabit 001 and 00 between R2 and R3. In my case, I will use gigabit 10 and gigabit 00. And between R1 and R3, serial 010 and serial 011 on both sides. On R1, I will use serial 30 and serial 30, and R3 serial 31, R3 serial 31. Okay, and the labels, if you want. Okay, start the devices R1, R2, start, R3, start. Okay, build a network, configure basic device settings. Okay, copy all this to Notepad. Okay, router R1. Hostname, no IP domain lookup, line console, loopback 0, loopback 1, gigabit 000. In my case, is gigabit 00. And the serial interface is serial 30 and serial 31. Okay, so modify this only gigabit 00, serial 30 and serial 31. Serial 30, serial 31, enter. Router R2. Okay. Hostname IP domain lookup, line console, loopback 0, loopback 1, gigabit. This should be 00 and 10. 00 and 10. Okay. 00 and 10. Router R3, enter. Hostname R3, loopback 0, loopback 1, gigabit 00, gigabit 30, gigabit, serial 30 and serial 31. Gigabit 00, serial 30, serial 31. Okay, very nice. And R1, click, double click. R1, configure terminal, and copy this. Right click to paste. Okay, very good. No errors, no issues. Go to R2. Okay, configure terminal on R2. Configure terminal. Then copy this. Right click to paste. Okay, very good. Go to R3, double click, configure terminal, and copy the R3 basic configuration. Right click to paste. Okay, very good. Okay, configure MP-BGP on all routers. Multi-Protocol Bgp. Implement eBGP and neighbor relationship on R1 for IPv4 and IPv6. Okay, go to R1. Okay, this is R1. Exit. Global configuration mode. Enable IPv6 unicast routing. BGP autonomous system 1000. Autonomous system 1000. Router ID. IPv6 unicast routing. Router BGP 1000. BGP router dash ID 1111. Based on the topology diagram, configured all the designated IPv4 neighbors for R1. 3 neighbors, 10.122, remote autonomous system 500, next hop 10133, autonomous system remote 300, 10130, remote autonomous system 300. Okay, 10122, remote autonomous system 500, 10133, autonomous system 300, 10130, autonomous system 300. Okay, remember on R1, be careful and neighbor 10122, remote autonomous system 500, 10133, remote autonomous system 300, 10130, remote autonomous system 300, enter. And now, based on the topology, use IPv6 neighbors for R1. Okay, 10122, 10122, 10133, 10143, 10122, 10133, 10143. Okay, neighbor 2001, DB8, ACAD 10122, remote autonomous system 500, enter. 10133, remote autonomous system 300, 10143, remote autonomous system 300, enter address family configuration for IPv4 and activate each IPv4 neighbors. Okay, go to address family, address-family IPv4 unicast, and activate these three neighbors. Neighbor 10122, activate. 10133, activate. 10130, activate. Exit from others family and enable the neighbors for IPv6, others family IPv6 unicast, and 10122, activate. 10133, activate. 10143, activate. Exit from IPv6 address family. Now the same configuration for R2. Obviously, according the topology. Okay, R2 has two neighbors, 1 and 2, two neighbors. Go to R2, exit, router BGP. Enable IPv6 unicast routing, don't forget that. IPv6 unicast routing. Router BGP 500, autonomous system 500. BGP router ID to neighbor 10.121, the IP address on the neighbor remote autonomous system 1000. Now you can see the adjacency with R1. You are on R2, but you can see the adjacency with R1 is up. The another neighbor 10.2.3.3 remote autonomous system 300, and the neighbors for IPv6 2001 DB8 ACAD 1012 ::1 remote autonomous system 1000. Okay, 2001 DB8 ACAD 1012 ::1. Okay, very good. This is the for R1 neighbor. Enter. Then another neighbor 1023 ::3 remote autonomous system 300. Enter. And activate the neighbors on address family. Address family IPv4 unicast neighbor 10.121 activate. Neighbor 10.233 activate. Exit. For IPv6 1012 ::1 activate. (1023 ::3 activate. Activate. Exit. Now you can see the neighbor adjacency with R1 with this command. Okay, activate the neighbor R1 and activate the neighbor R3. Okay, this configuration. Finally, configure R3. Okay, IPv6 unicast routing router BGP 300 BGP router ID 3 neighbor 10.232 remote autonomous system 500. Okay, you have three neighbors, 1, 2, and 3. Okay, 1, 2, and 3, three neighbors. Now you can see the adjacency with R2. The next neighbor 10.131 10.131 remote autonomous system 1000. 10.131. Enter. Okay, the adjacency with R1 and 129 remote autonomous system 1000. Okay, the network adjacency with this passive. Okay. Okay, you have two networks, but the second is passive. Networks on IPv6. Network 2001 DB8 ACAD 1023 column 2 remote autonomous system 500. Okay, enter. The next 1013 colon 1 1013 colon 1 remote autonomous system 1000. Okay, and 1014 colon 1 remote autonomous system 1000. Address family IPv4 unicast network 10232 activate 10131 activate 10139 activate. Okay, the three networks exit from IPv4 address family and IPv6 address family unicast. Network 1023 colon 2 activate. Okay, wait a moment, and you can see the adjacency with R2. 1013 colon 1 activate. The adjacency with R1 1014 colon 1 activate. Okay, this is the network adjacency with R1 and exit from IPv6 address family. Advertise IPv4 and IPv6 prefixes on R1. Okay, these are the internal networks 192.168.1. The network is 10. Okay, 11 is the host, 10 the network, and 192.168 64 the network, 65 the host, 64 the network. Okay, and advertise. Go to R1. Router configuration mode and BGP address family IPv4 unicast. Okay, router configuration mode in BGP address family IPv4 unicast. Advertise network 192.168.10 mask 285.224. Another is 64 192. Okay, exit for IPv6. you have 1000 colon colon prefix 64 and 1001 colon colon prefix 64. Okay, IPv6 unicast. The network 1000 colon colon prefix 64. Okay, advertise this network 1001 colon colon prefix 64. Pretty nice exit. And for R2, okay, go to R2. Router configuration mode in router BGP. Address family IPv4 unicast. Network 192.168.2.0 mask 285.225.285.224 and 2.64 mask 192. Okay, exit. Address family IPv6 unicast. Network 2001 DB8 ACAD 2000 colon colon prefix 64. And 2001 colon colon prefix 64. Exit. Okay, and finally on R3, router configuration mode on router BGP. Address family IPv4 unicast. Network 192.168.3.0 mask 255.225.225.224 3.64 mask 192. Exit. IPv6 unicast. Address family. Okay, network 3000 colon colon prefix 64. Okay, enter. And 3001 colon colon prefix 64. Exit. Notice that the networks between the routers are not being advertised in external BGP, in eBGP. Okay. For example, on R1, you are advertising the IPv4 and IPv6 networks of loopback 0 and loopback 1. Okay. On R1, advertising the networks for loopback interfaces for IPv4 and advertising the networks for IPv6 loopback 0 and loopback 1. But you are not advertising the gigabit interface, neither the serial interfaces. Typically, only the prefixes of the autonomous system need to be advertised in eBGP, external BGP. eBGP networks are typically directly connected and therefore will be able to form an adjacency. There is typically no need to advertise and inject the directly connected prefixes into the BGP routing table. Verify multi-protocol BGP. Display detailed network adjacency information. Use show BGP all networks command on R2 and display the detailed information about BGP connections to networks for all IPv4 and IPv6 address families. Each neighbor shows that is in the established state. This indicates that the router can send and receive BGP messages. R2 has two neighbor addresses, R1 and R3, for each address family, IPv4 and IPv6. So go to R2 and verify for R2, neighbor R1 and neighbor R3. Okay, show BGP all neighbors. Show BGP all neighbors. Space, 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 space. Okay, and now you can see the neighbor 10.1.2.1 is R1, 10.1.2.1 R1 is IPv4. The remote autonomous system on R1 is 1000. Established. Another neighbor is BGP neighbor 10.2.3.3, 10.2.3.3 on R3. The remote autonomous system 300 established, and for IPv6 10.1.2.1 on R1, autonomous system 1000, router ID and established 10.1.2.1 on R1, BGP neighbor 10.23:3, remote autonomous system 300 on R3, router ID established. Okay, very good. The command show BGP neighbors is used to display only BGP for IPv4 adjacencies. To display the same information for only IPv6 neighbors, use the command show BGP IPv6 neighbors. What is the BGP state for each neighbor adjacency? Established. Okay, established. How often are BGP keep alive sent? Okay, keep alive interval is 60 seconds. How many seconds will a BGP session remain open if no further keep alive messages are received? Hold time is 180. Display summary neighbor adjacency information. Use the show BGP IPv4 unicast summary and show BGP IPv6 unicast summary commands on R2 to display a summary of IPv4 IPv6 peering information with R1 and R3. The information displayed using the show BGP IPv4 unicast summary is a subset of show IP all BGP command. Okay, on R2 show BGP IPv4 unicast summary, enter show BGP IPv4 unicast summary, enter. Okay, the local autonomous system is 500. Okay, local autonomous system 500 on R2, and the neighbors 10.1.2.1 is R1, autonomous system on R1 1000, another neighbor 10.2.3.3 for R3, autonomous system on R3 300. The version of BGP is 4, not version of IP. Version of IP is IPv4, but the version of BGP protocol is 4. Okay, very nice. And the same command, but for IPv6, show BGP IPv6 unicast summary, enter. Okay, local ID, local autonomous system, neighbor on R1 10.1.2:1, autonomous system on R1 1000, network 1023, colon 3, autonomous system 300, okay, on R3, autonomous system 300. What is the difference between the local autonomous system number and the autonomous system number displayed in the list of BGP networks? Okay, what is the difference between local autonomous system number 500 and the autonomous system number in the list of networks? Okay, the difference that is the local autonomous system number for R2 is the autonomous system number that this router belongs to. And the autonomous system number on the list are the autonomous system number for the networks. Okay, the remote autonomous system number on the networks. Verify BGP tables for IPv4 and IPv6. Use the show BGP IPv4 unicast command on R2 to display its IPv4 BGP table. This command is equivalent to the show IP BGP command, and either command can be used. Okay, on R2, show BGP IPv4 unicast. IPv4 unicast. Okay, these are the paths. Okay, and notice that R1 shows 6 IPv4 networks in its IPv4 BGP table. Each network is valid with this sign and has one path which is the best path with this another sign. Okay, amongst the other information, the next hop IPv4 address and the autonomous system path are included. Okay, local router ID. So 1, 2, 3, 4, 5, 6 paths. Okay, but look at this. To reach this network 192.168.10.27, okay, from R2 to reach this network 192.168.10.27, the loopback 0 on R1, you have 2 paths. Using NetHub 10.2.3.3 is the R3, 10.2.3.3, and 10.1.2.1, and 10.1.2.1. Okay, both are with the asterisk and is valid. Okay, is valid, but this symbol, this sign is the best path. The best. So the best path is using R1. Okay, the best path using R1. Okay, a direct path. Okay, and look at this. The path. The first path using R3 goes through autonomous system 300 and then 1000. Okay, the first path with R3 goes to 300 and then 1000. With the direct path, the best path using R1 goes directly through autonomous system 1000. Okay, the best path goes directly to autonomous system 1000. Okay, the same case for 6426. Okay, look at this. 000 is the NATS hub for 192.168.2.0, and for 192.168.2.64 the NATS hub is 000, because These are local networks on R2. Okay, these two are the local networks, so you don't need a NAT hub. Okay, and this is the paths to reach the networks on R3, the loopback networks on R3. Show BGP IPv6 unicast. Show BGP IPv6 unicast. Enter. Okay, this is the same with for IPv6. Okay, for example, and now you can see, for example, to reach the network 1000 prefix 64. To reach this 1000 prefix 64, you have two paths, this and this another. Okay, you have two paths. Okay, the first path is the NAT hub 10233, 10233, and the another NAT hub is 10121. 10121. Okay, but the best is using 10121. Okay, this is the best because it's a direct path to reach this loopback network. Okay, this is the best path. Okay, using this symbol. Okay, is the best. And the NAT hub to reach 2000 prefix 64 and 2001 prefix 64. The NAT hub is IPv6 0. Okay, this is 0, the IPv6 0, because both are local networks on R2. So you don't need a NAT hub. That's why it's the IPv6 0. Okay, and these are the paths to reach the networks on R3, the loopback networks on R3. In the first output, show BGP IPv4 unicast. Y is 10.121, the preferred next hop address for 192.168.10 instead of 10.233. Okay, why this is preferred than this another? Okay, this is preferred because you need to pass through one autonomous system. The another path needs to go through two autonomous systems. Okay, that is why this is preferred. Why do some entries in the show BGP IPv6 unicast output include a NAT hub address of column? Okay, why are these column addresses? Okay, this is the unspecified address, and that means this prefix is generated by the local router. So these two networks are local networks. Okay, these two networks are local networks for R2. Viewing explicit routes and path attributes. Use the show BGP IPv4 unicast prefix subnet mask command on R2 to display all the paths for a specific route and BGP path attributes for that route. Okay, on R2, show the specific paths for 192.168.10 to 24. Okay, on R2, review the path to 192.168.10 prefix 224 is 27. Okay, very good. 27. Show BGP IPv4 unicast the destination 192.168.10, 255, 255, 255, 224. Enter. And now you can see the paths 2 available. The best is path number 2. Okay, this is the first path. This path goes through 2 autonomous systems, 300 and 1000, but and this another, and the second path 10.1.2.1. Okay, on R1, the router ID 1111. This goes through autonomous system 1000 directly. So this is preferred, the number 2, and this is the best path. Okay, this is valid, this another also valid, but this is the best. And use the same with for IPv6. Okay, show MP-BGP IPv6 unicast, and the destination is this 2001 db8 ACAD 1000:1 2001 db8 ACAD 1000 : prefix 64. Okay, enter. Okay, 2 paths available. The best is number 2. This the first path through R3. Okay, the router ID is 333. You need to go through 2 autonomous systems. This is valid. Another hop is through R1. This is the router ID 1111. You need to go directly through autonomous system 1000. This is valid and is the best, because the best is the second path, is this. Okay, and why does the output for the show BGP IPv6 unicast command include the link local address following the global unicast address? Okay, look at this. This is the global unicast address for the first path, and this is the link local address. This is the global unicast address for the second path, and this is the link local address. Link local addresses are used to send BGP messages. Okay. Use the show BGP IPv4 unicast networks IPv4 prefix advertised routes command on R2 to display IPv4 routes advertised to a specific network. Okay, show BGP IPv4 unicast networks. Okay, to R1. R1 is 10.1.2.1. Okay, 10.1.2.1. And show the advertised routes. Enter. Okay, and you can see this, the advertised networks. Okay, these are the loopback networks of R1, the advertising networks of the local router of R2, and the advertised networks for R3, the loopback networks on R3. Okay, and all this is advertised to the 10.1.2.1, this R1. And the same with using IPv6. Okay, show BGP IPv6 unicast networks. This 2001 db8 ACAD 1012:1 advertised routes. Okay, this is the network R1. Enter space. Now the advertised networks These are the loopback networks on R1, loopback networks on R2, loopback networks on R3. Why do some entries in the show BGP IPv4 unicast networks output include a NetHub address of 000, and the show BGP IPv6 unicast networks output includes NetHub address of column. Okay, you can see 000, column. Okay, this indicates that the local router generates the prefix. Okay, because these two IPv4 networks are local networks on R2. Okay, on the local router R2, and also these IPv6 networks are placed in the local router R2. Okay, on R2, these are placed on the local network. Verify the IP routing tables for IPv4 and IPv6. By examining the IPv4 and IPv6 routing tables on R2, you can verify that BGP is receiving the IPv4 and IPv6 prefixes from R1 and R3. Okay, on R2, show IP route BGP pipe begin gateway case sensitive G uppercase. Okay, and for BGP networks. Okay, the remote networks 1, 2, 3, 4. Okay, very good. And the same for IPv6. Show IPv6 and the pipe and section 2001. Okay, you can see the 4 BGP remote networks 1, 2, 3, 4. Configure and verify IPv6 route summarization. Summarizing prefixes conserves router resources and accelerates best path calculation by reducing the size of the table. Summarization can be configured either for prefixes originated by the autonomous system or prefixes received from downstream providers. Summarization also provides the benefits of stability by hiding flapping routes or having to install new prefixes when they are contained within a summary. Verify R2 and R3 are receiving 2001 DBA ACAD 1000 prefix 64 and 2001 DBA ACAD 1001 prefix 64 from R1. Okay, go to R2. Show IPv6 route BGP section 2001. Okay, these are the loopback networks on R1. On R3, the same command goes to R3 and show IPv6 route BGP pipe section 2001. Okay, these are the loopback networks on R1. Although Autonomous System 1000 only has 2 IPv6 prefixes, 2001 DB8 ACAD 1000 prefix 64 and 2001 DB8 ACAD 1001 prefix 64. This customer has been allocated the entire 2001 DB8 ACAD 1000 prefix 52 prefix. Okay. This prefix include this network and this another network. Okay. 52 includes these two networks. R1 is configured using the aggregate address command in IPv6 AF address family mode to summarize its IPv6 prefixes. This is now a summary route or aggregate route. The summary only option suppresses the more specific prefixes from also being advertised. Okay, and configure this on R1, the summarization. Okay, and router BGP 1000. Enter to address dash family for IPv6 unicast, and configure the summarization aggregate dash address 2001 DBA ACAD 1000 colon prefix 52 summary dash only. Okay, enter. And now verify on R2 and on R3. Okay, remember you configured this on R1. Go to R2 and verify. Show IPv6 root BGP. Now you will show only 3 BGP because this is summarized 52 that includes 2 networks. Go to R3, show IPv6 root BGP, and you will see only 3 BGP. Okay, before you see 4 BGP, now you see 3 BGP. 2001 DBA ACAD 1000 prefix 52. And very good. Okay, look at this. But also verify using show BGP IPv6 unicast begin network. Okay, go to R2, show BGP IPv6 unicast pipe begin network, case sensitive. Okay, and you can see the path to reach this path, this 1000 colon prefix 52. There are 2 paths. This is the first through R3, and this is the second through R1. Okay, so through R1 is the best path. Okay, this sign is the best path. Okay, and go to R3, verify the same command. Show BGP IPv6 unicast begin network space. And now to reach this network 1000 colon prefix 52, the loopback networks on R1, to reach this network you have 3 paths, 1, 2, and 3. The first through R2 1023 colon 2, 1023 colon 2, and 2 paths using the serial interfaces 1014 colon 1 and 1013 colon 1. 1014 colon 1 and 1013 colon 1. Okay, this is the best path through 1013 colon 1. This is the best path. This, okay, with this this symbol. If R1's 2001 DBA ACAD 1000 colon prefix 64 network went down, what would be the effect, if any, on the routing tables of R2 and R3? Explain. Okay, what happens is loopback 0 network is down. Okay, there would be no effect because the summary route will still be valid and advertised as long as at least one subnet within the summary route is still reachable. In this case, as long as 2001 DBA ACAD 1001 colon prefix 64 is still reachable, this aggregated route will still be advertised.